Hi, I'm Chris Anderson at the EE Web Tech Lab, and today I'll be looking at the LAPIS Development Board from LAPIS Semiconductor. If you're not familiar with LAPIS, it's probably because until recently they were known as ROHM Semiconductor and are now a ROHM Group Company. In any case, they're a well-respected semiconductor company that's been designing processors for decades. The LAPIS Development Board actually features two of their latest low-power MCUs, the ML610 Q111 and Q112. These MCUs are based on LAPIS's proven U8 RISC CPU, an 8-bit core executing one instruction per clock cycle, yielding performance on par or better than typical 16-bit cores executing one instruction for every 3 clock cycles. In addition to communication protocols, ADCs, memory, and other common MCU features, the Q111 and Q112 integrate the logic power supply regulator, low and high-speed oscillators that can be used in place of an external oscillator, and 6 channels of 16-bit PWM. One of the target applications for these MCUs is LED lighting control, so having multiple PWM channels integrated enables control of both brightness and color while reducing design footprint. The board itself has the Q111 and Q112. For development, there is a breadboard-style prototyping area, and each MCU has a Raspberry Pi compatible header, so you can use Raspberry Pi expansion boards with this dev board. There is also a header for LAPIS's debuggers and a micro USB port for connecting to the PC app for testing and development. To use the app, you'll need to make sure that your controller has the correct app firmware loaded, plug in your USB port, and launch the app. When the app opens, you'll see that there's this configuration guide to help make sure that you get the jumper set to the correct position for the desired MCU. In my case, I'm going to be using the Q112. And then you need to select the correct COM port. Usually that will not be COM1 or COM3. In my case, it's COM8. So then I click Open Port, and you'll see that this changes from not connected to connected. Now I have access to all the GPIO and I2C functions of the development board. So for this demo, I have C0 connected to my multimeter. So if I come over here and set all of these to outputs, and I can set all high or I can set all low, and really all that I care about is that C0 goes high so that we can see that on the meter. So if I set that output, it should go to 5 volts. And of course I can set them all low and it'll go back to 0 volts. On port D, I've connected D5 to my regulator output. So if I get that input, you'll see that it registers high here. You'll also notice that there's a guide down here to help you figure out which pins are where. There's also access to a couple pins on port B. And there's also an I2C tab, so if you have an I2C device that you're trying to work with, you can come in here and you can send it data. You can also read data from it, and that's running on pins B5 and B6. The LAPIS Development Board is unique in that it has both the Q111 and Q112 MCUs on board, expansion via the Raspberry Pi compatible header, and an easy-to-use PC app for quick development, debugging, and prototyping.